Good afternoon, everybody. Now I am going to talk about laboratory methods and identification of ants to the subfamily level. It's very important to know the laboratory methods, uh, and then how you can identify an ant to the subfamily level. Well, I would like to first describe the morphology of a worker ant. Usually in your day-to-day life, you see work ants around you, right? So pick one and then you can follow the laboratory procedure I described here, and then you can identify to the subfamily level if only you know the basic morphology of a worker ant. You place an ant under the low power stereo microscope, and then if you look at the frontal view, if you look at the ant head from the front, right, it's called frontal view. This is the head. You find compound eyes here and here, and I will introduce the other parts one by one. Here, only on one side, maxillary pulp and labial pulp shown. In ants, you see biting and chewing type mouth parts. In biting and chewing type mouth parts, or you can also call mandibulate mouth parts, you find mandibles, a pair of mandibles here, 1 and 2 pair of mandibles on each side, clypeus. This is a part of the labium, a pulp, labial pulp, and this is a part of maxilla, maxillary pulp. In addition to that, on the head region, you see these frontal lobes, and there is a sort of line, vertical line. It's a sort of ridge. It could be ridge as well or depression as well. It's called frontal carina and frontal lobes. This is the antenna. Usually in ants, you find geniculate antenna. Here, it's elbow shape. Geniculate means it's elbow shape. And in addition to this scape, pedicel, and these segments, apical segments of the flagellum can form a club. Club means two segments may be enlarged to form a section which is different from the other segments. And here in the clypeus, you might see this part is of this shape, and sides are narrow, right? So narrow sides are called lateral carina. When you look at the worker ant in this manner, this is called lateral view or profile. This is called lateral view or profile. Observe the ant in this view, then you see following sections, regions. Head, this is the head region. From here to here, you see L trunk. Here to here, excuse me, L trunk, and followed by the L trunk, you see petiole and postpetiole, petiole and postpetiole. There can be this sort of node on the petiole and also another node on the postpetiole. So this is called petiolar node. This is called postpetiolar node. And followed by these two, you find the gaster, on the gaster region, right? And this segment is called pygidium. This is called pygidium. This is the sting. This is the sting, and that is actually used for stinging. but in other words, this is a worker ant, this is a female, but this is used by the queen for oviposition. Then there are some other terms I want to introduce. Is the compound eye, pair of mandibles. You don't see mandibles in this manner in all lands. It's variable, but they have mandibles. And the clypeus, right? This is geniculate antenna. Geniculate antenna, maybe with the club or without club. This is the place where the antenna joins with the head is called antennal sockets. So antennal sockets are there, and there could be this frontal carinae and frontal lobes also here. It's not labeled. The posterior margin is called occiput, and on the thorax, see pronotum, mesonotum, and this part is called propodium. So metathorax sometimes may be reduced or present, but usually it's here joined with the first abdominal segment to form the propodium. So propodium, you should know where it is, and then in the leg, coxa, trochanter, femur, tibia, tarsus. Those are the segments. Those are really important for the tibial spur and pretarsal claws present. So there are many other features which are very important in the classification of ants. Okay, now Dr. Sudesh explained the field methods to you. After collecting those ants, or after each method, you preserve ants in 70% ethanol, or depending on your purpose, if it is for a molecular analysis, you preserve the ant in absolute alcohol, or you call absolute ethanol. And instead of ethanol, you can even use isopropyl alcohol. Now, okay, assume that you have ants preserved in ethanol. Then for this classification studies or taxonomic studies, you need to prepare a dry mount of an ant. I mentioned earlier in one of my lectures that there is the handbook prepared for the training workshop, which is uploaded to the website. So this is the information on pages 21 to 26 of the handbook. Right. Here we are looking at the materials required for the preparation of a double mount. We usually double mount ants. So we need materials for the preparation of a double mount. We usually do this in the laboratory, giving the participants a chance to do the practical or develop the practical skill on their own, right? But this year, unfortunately, we cannot conduct that laboratory session. Only the online lesson is here. Materials required for the preparation of a double mount are as follows. You need card. Just be familiar with the terms first. I will show you images, and at the end of this presentation, a video for more explanations. So card triangles, you need card triangles. So this is actually a point. You call them points. Points, insect pins, number 3 and 5 preferred. So you can purchase, I don't think we in Sri Lanka don't have a place to purchase these insect pins directly. But usually these are not normal pins because normal pins get the rust after some time. But these insect pins are not so. There are numbers according to the width and the length of the pin. There are numbers given. So insect pins number 3 and 5 preferred. Step blocks. You need a step block. Water soluble and quickly drying glue. Water soluble and quickly drying glue. A pair of fine forceps and a paintbrush. Insect display box. And worker ants preserved in 70% ethanol. As I said earlier, you collected using any field method. Materials, I said that points or hard triangles, these are, you can cut these from a bristle board or any hardboard. Then take that and cut triangular pieces. So triangular means one end is narrow and pointed, the other end has this, just like in a triangle, this base. Then these are entomological pins. These are called insect pins also, and they are of stainless steel. Stainless steel. This is a step block made in wood. This is a step block again made up of stainless steel. Made of stainless steel. Each of these is called a step block. Well, this is an insect storage box, or you can say display box. This is made up of wood, right? It can be again made of many other materials, even glass here. Anyways, you can add a transparent roof to the box. This has a sort of material, not rigiform, but a kind of form through which you can pin. Therefore, you can keep it as a box of ants that can be displayed. So this is what you should do. Actually, from here onwards, I give you stepwise instructions. Place a card triangle on the step block. Place a card triangle on the step block. Pin through the center base of the card triangle and move the triangle up carefully by fine forceps. The distance between the pin head and the point is usually about 1/3 of the total length of the pin. Then at the end of this presentation, you can watch a video. So that will give you more information. Pick a work ant in ethanol and place it on a filter paper. This is actually to blot it, or blotting paper, and let it become dry as much as possible. If the specimen is dry as much as possible, then it's very easy to see the body morphology. Body sculpture, where this clypeus structure and others that you should check for identification. Next, evert the mandibles by gently pressing down the head with 2 insect pins. Please note that this should be done while observing the specimen under low power stereo microscope if the worker ant is small. Now, apply a minimum amount of glue with an insect pin on the pointed tip of the card triangle fixed to the step block. Right now it's fixed to the step block. While it is there, you add a very small amount, very small minimum amount of glue with an insect pin on the pointed tip of the card triangle. Place the ant transversely on its dorsal side. Right, you place the ant transversely on its dorsal side while holding it with a fine forceps or a fine paintbrush. Because when you do these sort of practicals in the laboratory, you get used to handle the ant with a fine forceps or a fine paintbrush, usually number 0, paintbrush number 0. So whichever is convenient to you is recommended. Head of the ant must be on your right when the tapering end of the card triangle is directed away from the mound. That means you know that one end is tapering and very narrow pointed. So that end, when the tapering end of the that is directed away from the mountain. So assume that that end is that tip is away from the directed away from you, and then head of the ant must be on your right. Okay, right. Here is the most important information. The coxae of middle and hind legs should only be in contact with glue. The coxae of middle and hind legs should only be in contact with glue. Because I'm telling you, otherwise, if you do have more glue, and if you're going to paste the ant to the card triangle using more glue, you will be embedding the ant in glue. So what happens is, once mounted, you cannot see its many of its morphological features which are to be observed for the classification of the ant. So that is why I have written in here in red, do not embed the ant in the glue. Do not embed the ant in the glue. So if the first one is unsuccessful, you can try more and more until you become successful in this mounting. And you usually need to prepare several mounts of similar or different types of workers, because I mentioned this in some ant species, they are only monomorphic. They have only one worker, one type of worker. Then in that case, you may need one or two mounted specimens. But in some ant species, you find polymorphic workers. That means there will be more than one type of worker. So workers, if monomorphic, as I said earlier, they are of similar shape and with similar morphological features. But if they are polymorphic, they can be of different morphological appearances. Externally, they will, for example, in feedall, you find minor and major workers. Major workers are completely different from the appearance, so that you need to prepare at least two of similar types of workers or different types of mounts of different types of workers. Then, okay, now assume that you have completed the mounting of ant, and then what you have to do is you have to add a label. So you have to add a label or several labels with collection data. So you have to cut it using A4 paper. So cut a rectangular shape piece of paper, and then you have to add that to the each ant mounted by yourself. So in the label, what would you write? You're supposed to write exact locality where the ant was collected, if available, latitude or longitude and altitude, and date of collection. Usually you write this information by a pencil. Usually you write this information using a pencil. Habitat, nest site, method of sampling, and name of the collector, level of identification and name of the person who identified it, did the mounting, and colony code when it was collected from a colony. For example, actually, if you are collecting many colonies, you can have your own, in your own collection, you can give codes. So this is one of these. So if at least, I think at least if you are unable to write all, you must write the locality, date of collection. You must write the name of the collector, name of the person who identified the ant. For determining the taxonomic level, the mounted ant should be kept under low power microscope at suitable magnifications and observe, right? Observe as much as possible its classification, taxonomic features. The dry mounted ant should be later, you can pin it in an insect storage or display box that is for long-term use. Drying of the mounted ants is necessary for the long-term preservation. Usually, insect storage or display box containing dry mounts can be kept at 35 degrees centigrade in an oven for 3 to 4 days. That is for further drying or dehydration. Now, in addition to that, okay, now assume you have followed the procedure and now you have dry mounted ants with you. Now what to do? Actually, in addition to the dry mounted ants, you may need several wet preserved specimens of the same species. Therefore, if the ants are small, because I always mention small, that means under the low power microscope, you might not be able to count the number of segments in the antennae or mandible palps or maxillary palps. Therefore, you need to keep wet preserved specimens as well. So what I suggest is, if the ant is small, I have mentioned 2 millimeter or less, place the ant on a microscopic slide and detach the above appendages. So detach antenna, a mandible, a maxilla, antenna, mandible, and maxilla, and then add a drop of glycerine and observe under high power microscope. Add a drop of glycerine onto the dissected appendage, then observe under high power microscope at higher magnifications for counting the number of segments in each of these antenna, mandible, and maxilla. Actually, you dissect these and in the palps, number of segments are counted. So locate the mandible palp and mandible palp of the mandible and maxillary palp. And I'm really sorry. I'm sorry. So you dissect the antenna, count the place it on in this manner, and observe the antenna and count the number of segments. In the mandibles, you don't have a palp. In the mandibles, what you observe is the structure, right? Sometimes you have to look at the mandibular teeth, like there can be processes, sort of projections, spiny teeth-like projections on mandibles. So in classification to the genus or species level, this is very important. The maxillary palps, if you dissect out the maxilla, you count the number of segments in the maxillary palp, and also so on. You can count the number of segments in the labial palps. The above method facilitates the counting of the number of segments in the antenna. That's what I mentioned, maxillary palps and labial palps of small ants. Okay, now how would you identify the mounted ants to the possible taxonomic level? Place a dry mounted ant under the low power stereo microscope and observe all taxonomically important features of the specimen. For this, you can actually first you should learn the taxonomic terms I mentioned in the profile when explaining the profile view of the ant. Those are the features that I mentioned here. Taxonomic keys, if available for subfamilies, genera, and species, should be followed for the identification. So there are nowadays, when I started ant research, there were no such keys, very rare, very few were available into 1999. But nowadays, you are lucky if you want to refer to some taxonomic keys, they are available, but not that much again. But there are keys available for Indian continent, Asia region, and also global level. But not for all subfamilies, not for all genera, and not for all species. So be careful. Sort the first, during identification, sort the specimens to subfamily level first. Today I am going to show you how to sort the specimen to the subfamily level only. So after my speech, Dr. Jaitrong from Thailand will explain to you the identification of ants to the genus level, right? In my talk here, I will only explain how to sort the Sri Lankan ants to the subfamily level. How to sort the Sri Lankan ants to the subfamily level. And also Dr. Jaitrong will be doing the same. He will be introducing genera present in Sri Lanka. Next, proceed with the generic level keys or morphological descriptions. This is subfamily level identification is not that bad. You can achieve that. But identification to the generic level nowadays is difficult, because earlier we had a good reference which is Bolton, published by Bolton. I will show you. And but with further improvements in the classification, this generic level keys published by Bolton. It's a huge book. Some of them are valid until today, some of them are not. So we have to use that book very carefully, knowing what is valid, knowing what is not valid. But then sometimes many and scientists have published morphological descriptions so that you can follow those for further identification also. So listen to the presentations of other resource persons. You will get more knowledge on this subject. Refer to the published papers on ant taxonomy also. Now I'm describing here. Well, I have not included the books here because in my regional center for Asian Ant Research website, there is a reference section. So you can go there and see if you are planning to do a research in the future on ants, then you can find most important references listed there. And also you find papers published by us are added there. Most of them can be downloaded from the relevant website. So Bolton's Catalogue of the Ants of the World, which is a book which describes the ants recorded all over the world. Actually, history is here very nicely catalogued, right? But there is no morphological description, only the names there and from where it is recorded, and all that information is there. So I didn't purposely mention that Bolton's book, which is at the time that I started ant research, it was very valuable to identify ants to the subfamilies and genus level. As I said, it's still valid for some subfamilies and some genera. Then you can, although there are no keys, this one you can try. There are many images added. So visit that website and see what you can do there. And then www.antbase.org. This is also very useful for Asian ants. This will provide you keys and again images of ants identified. This one we prepared under my supervision. My students did that, but unfortunately there's a technical problem. We can't update that. Right? We are trying to do it. The person who actually 4 or 5 people together did this. Now we can't find how to update. Now there's a problem. But still you can visit the site. And following links are useful for the information on ants of Sri Lanka. Again, on Ant Web, there's a page for Sri Lanka, right? You visit those and see the list. But still remember, information on the pages yet to be updated, however, because this in here also there are certain things to be corrected. There are certain names to be added. So it's not complete in any way. Now moving on to subfamilies with the single genus. So first I will introduce subfamily names together with how many genera included in each subfamily recorded from Sri Lanka, right? So the subfamilies with a single genus recorded from Sri Lanka, one Anuretinae, one Anuretinae. In Anuretinae subfamily, Anuretus simoni is the only extant species that is living species, right? From all the countries in the world, still Anuretus simoni has been recorded from Sri Lanka only. So it's island endemic. It's island endemic and is of very importance because it's known earlier as critically endangered, but now we know it's not that. It's not in that status. We have actually reported it as endangered because it's been recorded only from Sri Lanka. And Ectotomine Namtogenis, although this subfamily is mentioned under the Sri Lankan ants list, but I have never found one yet. It's the only example is Namtogenis. And in Pseudomyrmecinae, inside Pseudomyrmecinae, Tetraponera species are there, one genus. It's Tetraponera, and I forgot to mention one thing. This subfamily Anuretinae includes many fossil species. That is why I mentioned this is the only extant species. And this one recorded in 2018, Proceratinae, because only one Discotheria specimen was found. But then it's also almost not a very good specimen. But we found it, we confirmed it. So it's Discotheria. That is the only genus found from Sri Lanka. So the subfamilies are Anuretinae, Ectotomine, Pseudomyrmecinae, Proceratinae. They are only with a single genus. Okay, subfamilies is two genera recorded from Sri Lanka. So you find two genera, that is only one, Amblyoponiinae. So earlier, this Amblyoponiinae included Amblyopon from Sri Lanka. Amblyopon, we identified, we found it from many habitats, but later in a revision, taxonomic revision, it's been recorded as a Stigmatoma species. So now this is Amblyopon is placed in this genus Stigmatoma, one genus Stigmatoma. I'm mentioning it again and again because even in my publications it's mentioned as Amblyopon earlier. This revision came in about maybe 5 years ago, 6 years ago. So, so you should know both names. The other one is Prionopelta, which we recorded in 2018. We recorded this from Sri Lanka in 2018, Prionopelta. Then the other subfamilies, Doryline, there's something very important mentioned here. Earlier, we had three subfamilies. One is Anictinae earlier, and were classified under three subfamilies, Anictinae, Doryline, and Serpentine. Anictinae, Doryline, and Serpentine. In a recent taxonomic revision, this Anictinae and Serpentine was included or transferred to Doryline. All members of Anictinae and Serpentine were moved to or transferred to subfamily Doryline. So now only Doryline is valid. Doryline is valid. Even in my publications, you will see Anictinae and Serpentine, right? But now, recently only this happened. So Doryline is the only currently valid subfamily. So Doryline currently includes several genera: Anictus, which was earlier in Anictinae, Serapes, Leoponera, Usiria, Parasisia, and Sisia. Leoponera we reported from Sri Lanka recently. Usiria we reported from Sri Lanka recently. And Parasisia and Sisia, all these were 1, 2, 3, 4, 5 earlier known as members of Serpentine. And the other one is Dorylus. So Dorylinae earlier included only the Dorylus genus. Now all these are included in Dorylinae subfamily. So I'm going to explain a subfamily key in slides 20 and 29, 20 to 29. So in this presentation, from slides 20 to 29, I'm going to explain a subfamily key. So in that subfamily key, using that subfamily key, if you have sorted the specimen to Anictinae, that is step 6A, Dorylinae partly. So now I have revised it in this manner. This is the key step in the key, step 6, part A. I have mentioned Dorylinae partly, right? Actually, if you do sort the specimen there to Dorylinae, that is Anictus. So the genus is that is Anictus. And as this is the subfamily key, I don't mention that, but you can keep that in mind. If you sorted a specimen using that subfamily key and you end up with Dorylinae step 9b, Dorylinae step 9b, that is Dorylus. That is Dorylus, or the members of earlier known subfamily Serpentinae. Both can be true. Dorylus or the members of earlier known subfamily Serpentinae. So far, we had serpentine species with two segmented waist only. I mentioned here purposely because if you observe a Dorylus, I'm going to show you Dorylus. Dorylus usually has only one segment in the waist. That means petiole only. Petiole only in the specimens found in Sri Lanka. But serpentine species, we had two segmented ways, so there is no problem to separate them later. So I'm not bothered about teaching you how to sort them to the genus level, but I must mention these three because in my key there are two places where you sort Dorylinae. If that happens at step 6A, that is Anictus. If that happens at step 9B, that is Dorylus or the members of earlier known subfamily Serpentinae. Then subfamilies with more than a single genus. Subfamilies with more than a single genus recorded from Sri Lanka is continued. So in Dolichoderinae, the other subfamilies are Dolichoderinae, Formicinae, Myrmicinae, and Ponerinae. In Dolichoderinae, species recorded from Sri Lanka are Bothriomomex, Dolichoderus, Tapinoma, Ochitales, and Technomyrmex. But Bothriomomex is like, there was a confusion with Bothriomomex. I am unable to identify Chronocenus here in Sri Lanka. So as I remember, this Bothriomomex is now a junior synonym, and there is a senior synonym for this. It's Chronocenus, but I haven't got any specimen, so I can't say exactly that is Bothriomomex or Chronocenus. Right? There was a revision, taxonomic revision. Formicinae, there are many genera. Myrmicinae, many genera. Ponerinae, many genera. So among these subfamilies, Formicinae, Myrmicinae, and Ponerinae, you find the highest number of species in Myrmicinae, then Formicinae, and then Ponerinae. Okay, now moving on to the taxonomic key for subfamilies actually prepared by me. Taxonomic key for the subfamilies prepared by me. Looking at the end, a single waist segment or petiole seen between the alitrunk and gaster. So this is the alitrunk, this is the gaster, this is the petiole. So if the petiole only is present, then go to number 2. Go to number 2 in the key. Two waist segments, petiole and postpetiole seen between the alitrunk ends. Go to number 8. Go to number 8. Then I said here, go to number 2. Then there are part A, petiole attached to the first gastral segment by the whole of its posterior surface. In profile, first gastral segment has no free anterior face dorsally. Okay, now again this is alitrunk partly drawn, this is gaster partly drawn, and this is the petiole. This is the petiole. So I'm talking about this junction. I'm talking about this junction. You don't find a free space here, right? For example, in here, this is the petiole, this is the gaster, this is the petiole, this is the gaster. You find a free space here, right? But in here, there's no such space. Therefore, we consider the petiole has the posterior surface. This posterior surface fully attaches to the anterior surface of the first gastral segment, right? Then it is a member of Amblyoponidae. It's a member of Amblyoponidae. Petiole never attached to the first gastral segment as above. So there is a free area on this surface, that is on the first gastral segment. So a free anterior surface visible on the first gastral segment. Now I am showing you this specimen image, which is Amblyoponidae subfamily, Stigmatoma genus. Here you see that this is the alitrunk of the ant and this is the gaster. This is the alitrunk and this is the gaster. This is the petiole, and this petiole joins with the gaster but not keeping any space on the anterior surface, right? Okay, that is a member of subfamily Amblyoponidae. There was, as I said, in 2018, we reported this genus from Sri Lanka for the first time, Prionopelta. And in Prionopelta, the same situation here, but unfortunately that this image has this leg actually covering the joint. But actually you can see that here there is no space, and if you observe the specimen laterally, there is no space over here between the petiole and the first gastral segment. Taxonomic key for subfamilies continued here. Now in here you have separated Amblyoponidae from your specimens. Now look at this. If this is so, petiole never attached to the first gastral segment as above, you go to number 3. Therefore you go here. Number 3. 3A, anterior peduncle of petiole elongate, slender and prominent, petiolar node well separated from anterior peduncle by the presence of dorsal and lateral swellings. Now in this figure, this part is alitrunk and this part is gaster. In between here lies the what? Petiole. What is this? This is the petiole. Here the petiole has a peculiar structure. Petiole is a peculiar structure. Why? There is a sort of narrow, elongated peduncle-like section. This part, narrow, elongated part. There is a swelling here, and as this is a lateral view, you can't see the lateral swelling here. Cannot draw the lateral. Only the dorsal swelling is drawn here. If you find any ant with this sort of petiole, it's a very peculiar structure, and this also the pair of spines on propodium, but petiole structure is very, very peculiar. It is a member of the Paenuretini. As I mentioned, subfamily Aenuretini has only one genus, which is Aeneuretes, and we have reported this ant from, I will say, a forest in many districts. Well, I will mention if I don't remember some. Sorry about that. I will actually mention that we didn't find it in disturbed habitats except in Pompakali Ratnapura, but then other forests, at least one forest in each district, Gampaha, Kalambu, Kegol, Ratnapura, Kalutara, Gol, and Madara. At least one forest we found, right? Anterior, if it is not this one, aneurethine, so that means anterior peduncle of petiole node never as above. Never as above. So go to number 4. In here, I am showing you aneuratus simony with the peduncle, the peduncle part and the node part, one structure petiole. That is the petiolar structure of the aneuratus simony. So it's a peculiar one. Look at this one. Look at this one. And then look at this one. Right? So this is the major identification feature of the subfamily aneurethine. Then I said that go to number 4. So number 4 is mentioned here. Observe the sting here, right? Sting at the tip of the abdomen. Sting visible and well developed. Sting visible and well developed. Then go to number 6. Visible sting absent. Sting may be present, but it can be protruded anyway. A visible sting absent. So go to number 5. Next step is number 5. In number 5, you need to observe the tip of the gaster. Tip of the gaster, but ventrally. You need to observe this ventrally. Ventral side should be observed. Apex of the gaster ventrally conical shaped and with a circular acidopore. Circular acidopore. It appears in this manner, usually covered this with setae, or at least one setal row is there surrounding the acidopore. But in some genera, such as Polyrachis and Camponotes, sometimes it's very difficult to see the setae. So, if so, it's a member of Formicinae. So, the specimen to the subfamily Formicinae. So, this occurs here, and in the ventral side, you see it in here, right? If not, if this structure is not there, apex of the gaster ventrally or posteriorly bears a slit-like or inverted V-shaped pore. Right in here, when laterally, in here ventrally, you see a slit-like opening, slit-like pore. Right. So that then the specimen is a dolichoderine. Specimen is a dolichoderine member. So you might wonder why I said V-shaped pore. When drawing this, it's almost like actually horizontal. But when you see it, it could be even V-shaped, right? Mostly V-shaped. Okay, now this is a Formicinae example. Just if you look at here very carefully with a good eye, right? You can see a fringe of setae. Setae are like hairs. This is a seta, but here you find a short setae together and a circular structure, circular one, acidopore. So in the lateral view, you see the acidopore in this manner. Okay, now go back. Here, visible listing absent. That is why I said that you go to 5. So there is no sting here. You can't see no sting here, but this structure is there. Cetal fringe with the circular acidopore. And for dolichoderine, I said V-shaped cut. That is why I said V-shaped cut. In lateral view, you might see it in this manner sometimes, according to how you keep the specimen. Okay, number 6, pygidium flattened and bears a pair or more than 2 pairs of small spines. And this one shows gaster. This is the part of posterior part of the gaster. There you see a pair of small spines, 1, 2. And here you find, actually this region is enlarged here. Posterior part is enlarged to show you the pair of spines. So a pair of spines present, or this is the pygidium. This is the pygidium. In here also, this is the pygidium. This is the pygidium. And here, several pairs present. Right. Then if you don't find such spines on the PGTM, and PGTM looks like this, curved, if the PGTM is curved and no spines, you go to number 7. Here you can sort Doryline members apart. Remember, it's not Doricoline, it's Doryline apart. Okay, Doryline examples, Serapagis and Dorylus are shown here. This is Serapagis, this is Dorylus, but both are Dorylines. So you can see two segmented waist here, two segmented waist, and in here only one segmented waist, petiole only, petiole and post petiole both here. So that this feature, PGTM flattened and bears a pair of more than 2 pairs of small spines, which is actually it's very difficult to show you. It's usually should be here, right? This is usually should be here. Then moving on to number 7 of the taxonomic key, where is that no spines on the curved PGTM. You go to number 7. So number 7, anterior clypeal margin with a narrow lamellar apron. Clypeus broadly inserted between frontal lobes. You can see it here. Clypeus, here, this is the margin of the clypeus. So it's inserted between frontal lobes. Frontal lobe here, frontal lobe here. This is inserted between frontal lobes, right? And then anterior clypeal margin with a narrow lamellar apron, this one. This is the clypeal margin. It's with a narrow lamellar apron. If so, that is a member of subfamily Ectotominae. If there is no such narrow lamellar apron along the anterior clypeal margin and clypeus narrowly inserted between frontal lobes, what does that mean? Here, from here to here, it's considered as widely inserted. Oh, I said broadly inserted, right? Broadly inserted from here to here. But narrowly inserted means it's narrow. You don't find this sort of wide or broad area, but you see very narrow region here, very narrow clypeus, very narrow clypeus. So this is a member of, well, this is the only genus Lamptogenis included in subfamily Ectotominae, and here one ponerine ant, which is Odontomagus, very common in our surroundings. Usually subterranean, and also even if there are several species of cardia, this is called cardia. Some say Dalacardia, right? Then moving on to number 8. If you remember number 8, that is because these members have two waist segments, petiole and postpetiole. In the first step in the key, part B was two waist segments present, right? Move to number 8 from there. Observe this tarsal claws. This is enlarged tarsal claws. This is an image of tarsal claws, right? Okay. And then where? Pretarsal claws, hind leg, right? Pretarsal claws on the hind leg without the preapical additional tooth. And there is no additional tooth. I can't show you the additional tooth. So in here, I show you the additional tooth. So in here, there is no additional tooth like this, right? Okay. Compound eyes, round and small to medium in size, and annulomorma. Well, I have to mention here, yes, when we prepare keys, we use the features found in the majority of them, but rarely, occasionally, in some specimens, you find eyes absent or minute in very rare Annulomorma and Caribera species. So eyes may be absent to very small. It's very difficult to locate, especially in Anylomyrma it's absent, but Caribera, very difficult to even find in the specimens, right? And if these features are found in the specimen that you are examining, it belongs to subfamily Myrmicinae. If pretarsal close on the hind leg with this sort of additional tooth on the inner margin, compound eyes large, elongate and bulged out. In this manner, compound eyes large and bulged out and elongate, then that is a member of subfamily Pseudomyrmicinae. That is a member of subfamily Pseudomyrmicinae. So this is a myrmicine ant, Myrmicaria. In the you can see two segments in the waist, petiole and post-petiole. If you examine very clearly, there is a sting present also. There's a sting present here. And in Pseudomyrmicinae also two segments in the waist, petiole and post-petiole. Here you find well-developed sting, right? And I mentioned their eyes are large, bulged out. And something else I mentioned, there is an additional tooth in the hind leg, right? Hind leg, if you focus on the hind leg and pretarsal claws, it's not, you can't see it here, but I'm just showing you where the pretarsal claws are here on the first leg, right? First leg. So similarly, you have to observe the tip of the leg to find the additional tooth on the pretarsal claw. You have to use a higher magnification. Then go to number 8. From where? Here 8A, 8B. Okay, thanks. Sorry, I was confused, right? Here A, B are there, right? 8, A and B are there. Okay, in case you can have another step. 8C is here. 8C is written here. Pretarsal close without a preapical additional tooth. Compound eyes absent. This is another condition, right? Pretarsal close without a preapical additional tooth, just like in Myrmicinae, and compound eyes absent. Compound eyes absent. Go to number 9. And these specimens are really known to lack eyes, right? Now go to number 9. Promesonotal suture, dorsally distinct. The promesonotal suture, dorsally distinct. It's drawn here. That means between pronotum and mesonotum, there is a sort suture. At the joint, you find a suture. You can see that these two are joined. And dorsally distinct, antennae 12 segmented. Antennae 12 segmented. So it's a member of subfamily Leptonillinae. It's a member of subfamily Leptonillinae. Then B is promesonotal suture not visible. So compare this and that, this and that. Here you can see this. Here you don't see that, right? Promesonotal suture not visible. Mesometanotal suture may be visible. In here, instead of this one, another one may be visible, but we are talking about this junction. Antennae 8 to 10 segmented. In this antennae 8 to 10 segmented, this then it is a member of Dorylinae, a part formerly known as Anictinae. A part formerly known as Anictinae. Here, I'm showing you a Protonilla specimen, Protonilla. It's a member of Leptonillinae subfamily. This is a very small specimen, but enlarged, magnified, right? And here I am showing you, if you are able to count number of segments of the antenna, as I mentioned there, you can count 12 segments, right? 12 segments, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can count it slowly, and 12 are there. And then I have mentioned pro-mesonotal suture, distinct. Pro-mesonotal suture is this one. So you have to observe it. Observe it very clearly. You will see. I'm sorry. This is the pro-mesonotal suture here. Well, I'm wearing spectacles, and sometimes, sometimes it's not very clear, right? Okay. Then this is Anictus. This is one of the Anictus members. Anictus, one species of Anictus, and there I mentioned the number of segments of the antenna 8 to 10, right? And pro-mesonotal suture, not in this manner, visible, not visible in this manner, right? This actually in drawings or illustrations or images, it's not possible to show you what I mean. So only thing is you have to have this specimen kept on the stage of the low power stereo microscope, went dorsal side up. In this sort of view, you can't see that feature very nicely, very accurately. Then moving on to the last one, subfamily Proceratinae. It's not included in the key because it was actually recorded from Sri Lanka in 2018. And the single genus Discotheria, and Discotheria specimens in a lateral view appears in this manner. It looks like that. One-way segment, and you can see the illustration shows one-way segment here, one-way segment. This is propodium, and this part is gaster. So very very prominent feature here is the bent segments, right? Last three segments of the gaster bent in this manner, right? That is a very peculiar feature that you can use to recognize it. There are other features as well, but this is really so. And you can see this is alitrunk is smooth, right? No sutures at all, smooth alitrunk. Okay, now I'm going to mention other publications. I mean, in addition to the websites I mentioned, I know that many of us are now actually used to go through internet resources, websites, and so on. We use books very, rarely nowadays. I think I read books, but I mean the young generation. So the first valuable guide to the ant genera of the world was, as I mentioned earlier, an identification guide to the ant genera of the world. This book is, as I said, valid still for some subfamily identification or descriptions, and it has a subfamily descriptions also, and for the identification of ant genera, but not completely valid because there were many taxonomic revisions after 1994. So revisions to his guide were added by publishing Synopsis and Classification Forms in 2003 also. I have both books. Many revisions have been added to the taxonomy ants during 2003 to 2020, especially after 2012. So that is why most of the published books, although very expensive and valid those days, some information are not updated, cannot be updated there. So if you are using, for instance, any of these guides, you have to keep that in mind. Thank you so much for listening. That is the end of my presentation.